Good afternoon. So Paul just went through an overview of the mission. I'm going to talk about an effort that was part of the community effort to help with ARM called the Formulation Assessment and Support Team. And again, I'd like to acknowledge Paul, who's a deputy investigator on the ARM mission, and David Reeves working with me at Langley as the analysis and integration lead, and all the FAST members. And I'm going to go through a list here in a second and kind of identify. I think we've got 8 out of the 21 folks that worked on FAST actually here. At least at one of the 2 conferences or workshops. So first, the FAST, it was chartered by NASA to provide timely inputs for our requirement closures TIM back in December of last year as part of the robotic mission. So the acronym was actually very apropos. It was a very quick effort. They assisted in developing, in addition to the requirements TIM, developing an initial list of potential mission investigations and provide input on different hosted payloads and potential partnerships. The focus for ARM and the FAST is on 4 individual areas that are linked. We've talked about them before, but science, planetary defense, asteroidal resources and in situ resource utilization, and then also capability and technology demonstrations. So it was composed of 18 members. NASA and non-NASA participants, plus myself, the mission investigator, Paul Abel and David. We had exactly 100 applicants, and this was it was a contributed effort. We paid for the travel to the meetings, but the time was contributed by the members, which was outstanding. We had our initial meeting in September of 2015 at Langley, and we had our final meeting at Goddard right before Thanksgiving. So in terms of the membership, this is just a list. You see the leadership at the top. Eric, I'm just going to go ahead and list everybody here. Eric Asfug, he was here at the Phobos Deimos conference. Nada Abreu, Jim Bell, Bill Botke is somewhere in the audience. Oh, he's in the other session right now, missing his talk. Dan Britt is here. Humberto Campins is in the back. Paul Chodas, JPL, is not with us here today. Carolyn Ernst, Mark Fries, Leslie Gersh, Danny Glavin, Christine Hartzell, Amanda Hendricks is here, or she was. Joe Newth, Dan Shears is in the back. And Joel Sorcell, Driss Takir, and Chris Acme were the members of the team. So again, basic emphasis was to provide information on the nature of the asteroid target, and the boulders and the regolith, and provide ideas and recommendations to enhance the scientific return, basically the knowledge gained from the mission. So here's a picture of the team. If anybody's counting, there's actually a couple project people in the back. So there's actually 23 people in this picture. If you want to do a Where's Waldo, you can try to find them. I don't have time to get into the results. I gave about a 45-minute to an hour overview of all the results at SBAG back in Monrovia in January of this year. But you can find them online at the SBAG website. Very, very easy to get to it, and there's a link in the presentation. As a final product of the FAST effort, we generated a final report, and we also solicited public comments and inputs along with that, and that was released back in February, and it can be found on that website there. It's also pretty easy to get to if you go to the General ARM website. The report provides an overview of the FAST efforts, responses to a set of high-priority questions that were derived from the engineering team, the project engineering team's risk analysis that were necessary in helping with the design and the development of the ARM mission, particularly the capture system and the operations. An initial list of potential investigations which could be performed by the robotic mission and or the crewed mission. List of additional findings by the FAST in combination with public input. A summary of those public inputs, and then also the complete set of public inputs were provided on the website, as well as some additional appendices. So basically the FAST identified ARM as a unique opportunity to gain a wide range of valuable knowledge beyond other asteroid missions and what is available in the current meteorite collections. A big part of what we're doing on the asteroid redirect mission is we're bringing back a multi-meter, multi-ton boulder where we can actually interrogate for the first time at depth to understand what the volatile and organic content is as we go down below the surface. So this is just an overview of those questions that the team was asked to look at. Basically, the origin and the thermal environment of EV5. And as Paul mentioned, our reference target is 2008 EV5, so a lot of the FAST effort was focused around that, but also extended to other types of objects and other classes of potential surface properties. The boulder spatial and size distributions, and basically based on radar data from 2008 EV5 and size distribution curves, we're estimating about 300 to maybe over 1,000 2 to 3 meter boulders that exist on the surface. Now, exactly where they are, their location, that's going to be part of the characterization. The surface geotechnical properties, trying to understand what the surface is going to act like, the compaction. The boulder physical properties, including, and also in the geotechnical properties, a big concern or a big unknown is the cohesion of the boulder to the asteroid. And so we're looking at a range of estimated values, basically between 25 and 250 pascals, a low gravity body with what is expected to be depleted fines, etc., on the surface, pebble-sized granular material. We also looked at the physical properties of the boulder in terms of the shear, compressive, and tensile strength, as well as the density. Discussions about, and there's information on post-collection boulder handling, some of the things you do want to do, you don't want to do, an assessment of the boulder for crew safety before we get the crew there, also containment considerations. And those findings are all included in the FAST report along with the appendices. So we provided an initial list of potential misinvestigations and inputs. These were not intended to be inclusive of all the possibilities. And again, I don't have time to list them all here, but they were identified in the areas that were most important to NASA in general, and also to ARM in specific in terms of providing risk reduction or additional data that could be useful during the mission. Listed in the final report, they were put in order that they were received, but we did some prioritization subsequent to that effort so that we could provide an input to future calls for instruments, which I'll talk a little bit about at the end, and the investigations that we would do. So based on the input from the FAST and the subsequent prioritization that we did at NASA, this is basically a top 10 list. It's not to say that this is the only payloads that we would be interested in, but these were of importance. Probably at the top, in terms of characterization of both the surface and the boulder, thermal imaging, multispectral imaging for composition, near IR spectrometer for assessing hydration, and organics and other things. It looks like this is I made a change to this, but it doesn't look like it flowed through over here. Regular geotechnical property estimation via surface interaction. And then one of the ideas was to use some sort of sensors. We focused kind of on acoustic and ultrasonic sensors to provide characterization during or after collection of the boulder. That could help out a knowledge of the boulder once it was captured. This is all done autonomously. I think Paul mentioned that, but we're not going to have time to do extensive testing before we actually grab the boulder, but we would like to have as much information as possible during the collection process and after. A free flyer with that provided camera or potentially orbit determination assets was seen as a top priority. Surface interaction from deployable payloads, and in situ resource utilization assets and experiments. Small carry-on impactor was another one that was identified to get subsurface geotechnical properties versus just a simple surface interaction to understand the higher levels. And then radar tomography to look at the entire surface, but in particular the near surface structure around the boulder using ground penetrating radar. And again, the payloads that can perform multiple investigations and reduce risk for the robotic mission are preferable at this point. So a summary of some of the additional findings by FAST. Again, as I mentioned earlier, we think there's a unique gain from ARM to provide the opportunity for a wide range of knowledge gained beyond other asteroid missions, what's available in the meteorite collection. One of the things was to do a goal traceability. We didn't go through and specifically address traceability to the current planetary decadal survey or other NASA exploration roadmaps, SKGs, but we are actually doing that now with the help of SBAG. One of the findings was that all existing data should be analyzed, and potentially if we can get any additional information or characterization of 2008 EV5 would be valuable. We really don't have time to launch a precursor or a CubeSat or a Neo Scout, but that certainly would be helpful if we had it. Meteoritic and simulant analog work, we're doing a lot of that, trying to understand the effects of simulant, doing both laboratory work as well as some analytical work. And as I mentioned above, the precursor would be helpful. One of the findings, and this is it's almost motherhood, the characterization of the target asteroid, the boulders, and the associated collection area are critically important. We've got a certain amount of collection or characterization time before collection. We certainly are looking at ways to improve that and speed up the process of the processing the data and getting that information to the project and allowing it to affect and be available for the operations. The geotechnical property estimation, again, understanding the cohesion, the friction angle, porosity is important, and of course the boulder regolith characterization, getting sufficient camera resolution and characterizing the relationship of the boulder to the surrounding terrain, as well as the physical integrity of the boulder is important. Thermal imaging comes up again here. It was one of the findings of the FAST that led to that being really kind of the number one thing that we would like to see as an additional information characterization that we would get. And then finally, there was a discussion about previously visited target. While selecting a C-type target that has not been visited before is compelling, and in this case, not Bennu or Ryugu, there's value potentially in returning to a previously visited asteroid. So we have 2008 EV5 as our baseline reference target, which has not been visited, but there could be value once Hayabusa 2 and OSIRIS-REx visit their targets. Public inputs to the FAST. Got 1 minute. Okay. As I mentioned, we had a final report that includes public inputs that we received. The complete set is posted on the website that I showed earlier. We also included inputs that weren't directly applicable to ARM, but they were in general. They weren't included in the report, but we did post them and folks can go over there and look at them. We basically documented the inputs from a total of 15 individuals representing a variety of affiliations, and they're listed in the final report in the order they were received. So I'll just close with their two upcoming announcements of opportunity. Right now we're planned for August with synopsis being planned to be released very soon, probably hopefully by the end of July. We had our key decision point B meeting on Friday, July 15th, and we're waiting on the final decision. And then these announcement of opportunities will come out. The first is an opportunity for partner-provided payloads to be hosted on the robotic spacecraft. The intent is for NASA to provide the launch of the vehicle, the spacecraft bus, the comms and operations, and we think there's a great opportunity for partnerships of providing a payload for increasing the knowledge return and potentially supplementing the mission. And then what Paul and I are going to be leading in particular is participation on the ARM investigation team. That call will be coming out along with the payload call, and this will be basically to provide expertise and support of the mission and investigations that we can do during in particular the robotic mission. It'll consist of U.S. and international members. We're anticipating an initial term up to 5 years. And again, it'll be focused on the 4 areas that I mentioned before, as well as providing program level and project level support. So with that, if I have any questions?
We have time for 1 or 2 questions.
Okay. Oh, Andy's coming
up. So Dan, I have a quick question. Are there thoughts about how to handle the dust that might be raised along with the sampling process?
Yeah, so as Paul described, we're trying to do everything to minimize interactions with the surface with thrusters. So we're doing, the nominal plan is we're going to do a mechanical push-off, a mechanical attenuation of the contact. We will be firing thrusters to maintain position, but they'll be pointed away from the asteroid. When we pull the boulder out, yeah, we potentially will get some dust, but the thought is that will be already traveling away and that wouldn't present a problem. Additionally, because of the small size of these asteroids, we're talking about sub-kilometer near-Earth asteroids, and the fact that they have very low gravity, a lot of the fines are depleted. So we think the dust is a relatively minor problem. That's something that we're looking at as well.
Sure.
I had a quick question on one of your, I think it was third from the last, about the different investigations that you wanted. The very last bullet mentioned reduce the risk to arm. Okay, what kind of risk are you referring to? Cost, schedule, technical, or helping the spacecraft stay safe?
Yeah, and generally that's talking about technical operations. The two biggest unknowns really are the strength of the boulder and the cohesion of the boulder to the surface. And so whatever we can do to better characterize that when we're there, that'll help with the selection process. So we have a LiDAR and visible cameras on the baseline. That's enough to do all the terrain relative navigation and do the 3D stereo mapping of the surface. But additional payloads that, like thermal imagers, spectrometers, are of value there. So this helps reduce the risk for arm.
Okay, one more question real quick.
Okay. For the, you said an AO would come out for the investigation team in August, I think. When do you think that would be due? And would the proposal, so to speak, look more like a roses kind of thing, or more like what was for the FAST, kind of just a short letter?
It's more towards a longer proposal, an in-depth. There'll be opportunities for postdocs, is our plan. So we want to understand the investigations and the individual that's coming to the team. The current target is for proposals to be due in the late August. Oh, golly boo. Let's get the right month here. The late October timeframe. So a synopsis will be coming out shortly. That'll give kind of a heads up, but that's the target, around October, and middle to end of October. Okay.
Okay, thank you, Dan. One more time. Next speaker is Victoria.